Solving radical equations. Today we're going to solve square root and other radical equations. To start with, let's review solving an equation in general. Whenever you solve an equation, you always do the opposite. What is the opposite of addition? Subtraction is the opposite of addition. What is the opposite of multiplication? Division is the opposite of multiplication. These things people know. That's not an issue. The problem is when I say, what is the opposite of squaring something? You'd be amazed at how many students tell me, well, I'm going to divide. Well, no, the opposite of multiplying is dividing. The opposite of squaring would be taking the square root. In that case, what is the opposite of taking the square root of something? The opposite of taking the square root is simply squaring. Now, what do I mean by taking the opposite? Well, when we're solving simple equations, we're doing PEMDAS backwards. So if I have the equation 5x plus 15 equals 25, I'm going to do my order of operations backwards. The opposite of adding is subtracting, and I'm going to subtract 15 from both sides to cancel out the 15, which gives me 5x is equal to 10. Then the opposite of multiplying, what is happening to the x? It's being multiplied by 5. The opposite of multiplying is dividing. So I'm going to divide both sides by 5, and that gives me x is equal to 2. Now this is normal. We know this. But when we come over here to squares and square roots, people get all confused. Well, what is the opposite of taking the square? The opposite of taking the square is taking the square root. Whatever you do to one side, you do to the other. And that gives me the answer of x is equal to 5. Well, then what is the opposite of a square root? The opposite of a square root is a square. So I square one side. Whatever I do to one, I have to do to the other. A square and a square root cancel out, and that gives me x is equal to 6 squared, which is 36. Here are the steps to solving radical equations. First, you need to isolate the radical. It means get that radical all by itself. Then you raise both sides of the equation to the index of the radical. Then simplify. What do I mean? Let's take a look. The first step is we look at what is happening to our radical in order to isolate it. It's being added by 2 and divided by 3. We do the opposites. We do PEMDAS backwards. The opposite of adding 2 is to subtract 2. Whatever you do to one side, you do to the other. Then you say, what is the opposite of dividing by 3? The opposite of dividing by 3 is to multiply by 3. What you do to one side, you do to the other. The 3's cancel out, leaving you with the square root of x is equal to 15. Now we can raise both sides of the equation to the index. Well, this is a square root. That means the index is 2, so we square both sides. And that leaves us with x is equal to 225. Now for the equation on the right, what's happening? It's being multiplied by 3 and it's being added by 3. So we're going to do the opposite of addition, which is subtraction, to cancel out our positive 3. Then the opposite of multiplication is division. Now we have a square root. The opposite of the square root is squaring. And that leaves us with x is equal to 16. Now here I can't necessarily isolate the radical, but what I can do is I can get the one radical all by itself on one side. The way I do this is I have the subtraction from the 1. The opposite of subtracting is adding. So I'm going to add this second radical to the other side. Now I have the radical all by itself on the opposite sides. The opposite of square rooting is to square, so I'll get to square both sides, which cancels out the square root on the left and also cancels out the square root on the right. At this point, it's a pretty easy problem to finish. You get x is equal to 5. This problem is very similar. Two differences though. There's no way of getting the 2 away from the radical. So I'm just going to have to deal with it where it is. Now, we want to get the radicals by themselves, but sometimes it's not possible. Also notice this is a cubed root. So the opposite of taking a cubed root is to cube both sides. The left-hand side is pretty self-explanatory. A cubed and a cubed root cancel each other out. On the right-hand side, there's 2 and the cubed root. Cube is going to talk to the cubed root, and the cube is going to talk to the 2. That's going to give you 2 cubed, which is 8 times, and then the cubed and the cubed root cancel each other out. to give you x minus 1. Now you need to distribute the 8 through and finish the problem. That leaves you with x is equal to 2. Here we have fractional exponents. We're going to follow the same basic steps. Remember, fractional exponent is basically a root. If I was to rewrite this, that would be x plus 3 to the 4th root to the power of 3. Before we get into that, the first thing I need to do is to get the radical by itself, so I'm going to divide both sides by 3. Now, if I look at this, I'm doing two things here. I'm cubing. So what is the opposite of cubing something? The opposite of cubing is taking the cubed root. So what that's going to do is I'm going to want to take the cubed root of both sides. At the same time, I am also taking a 4th root. That's the index. So if I'm taking the 4th root, then I'm going to want to raise both sides to the power of 4. And this is what it gives me. The cubed root and the cube cancel each other out. Power of 4 and the fraction of 4 cancel each other out. That leaves me with x plus 3 on the left-hand side is equal to, now we're going to work out the right-hand side. What is the cubed root of 27? Well, the cubed root of 27 is simply 3. Now it was being raised to the power of 4. 3 to the power of 4 is equal to 81. Now I simply have to get the x by itself, and x is equal to 78. Here we have a similar problem with a little twist. First, on both sides, we have an over 3. So remember, a 1/3 power is the same thing as a cubed root. So what I need to do is I need to cube both sides. When I cube both sides, the root and the cubes will cancel each other out. That leaves me with 2x minus 6 squared is equal to x. Now if I take the square root to cancel out the square, I'm still left with the square root on the right. I can't solve it with a square root, so I need to simply work out the square. If you don't remember how to work out a square, please refer back to multiplying polynomial video. Whenever I solve a quadratic, I always need to set it equal to 0, so I need to move the x to the left. Multiple ways of solving quadratics. You can choose whichever way you want. I'm going to solve by factoring. Remember, set each of your factors equal to 0. Here you're left with two answers, x is equal to 4 and x is equal to 9/4. Now this equation had two answers. Now I haven't made you go back and check them yet, but you always need to go back and check your answers looking for extraneous solutions. An extraneous solution is an answer that is not a valid solution to the problem. After solving an equation, you need to substitute the number back into the function to see if the solution works. So after we do all that hard work to find the answer, we need to see if it's actually working. Here's a couple examples. If I'm going to solve this equation, I can see that I have a radical. I need to get rid of that radical. So I square it. What you do to one side, you do to the other. The square and the square root cancel each other out. That gives you negative 3x plus 33 is equal to, and then you need to square these. I expect that you know how to do the squaring. Now since I have a radical, I need everything to be on the same side or set it equal to 0. The x squared is positive on the right, so I'm going to leave the x squared on the right, which means I need to add the 3x to the other side and subtract the 33 to the other side. When I write this, I'm going to write it in standard form with the x squared in front. I'm going to solve by factoring, set the factors equal to 0, and solve. Now, we're not finished. We need to check for extraneous values. So what that means is I'm going to take my two answers and plug it back into the original equation. Now, before I go any farther, I can still simplify this, but look, a square root equals -3. Can a square root ever equal a negative? And the answer is no. When I take a square root of something, I get a positive number. I don't get a negative number. If I was to finish this out, you'd have 3 equals -3. No, 3 does not equal -3. So that I know that x equals 8 is wrong. So we would call this an extraneous solution or extraneous value. And basically, you don't write that as your answer. Now, check the next one. Make sure you watch your negative signs, and when you work this out, you get 6 equals 6. Is that a true statement? Yes, it's a true statement. So our one and only answer is x is equal to -1. Always check for extraneous solutions. Again, we want to start by getting the absolute values. If I can't get them by themselves, I want them on opposite sides. So I'm going to move the square root of x to the other side by adding the square root of x to both sides. Now, in order to get rid of the square root, I square both sides. That gives me 5 minus x on the left-hand side. But on the right-hand side, that's going to give me something really big. If you don't remember how to multiply these out, go back and watch the binomial radical expressions, where I show you how to multiply binomials with radicals in it. Now that I've got rid of one radical, I need to isolate the other radical and do this all over again. After I move the x and the 1 over, I'm left with 4 minus 2x is equal to 2. Square root of x, I can still get rid of that 2. And then I get to square again. Now I have a quadratic that I need to set equal to 0. So I subtract the x to the other side. And I write it in standard form. I'm going to solve by factoring. And that gives me two answers of x is equal to 1 and x is equal to 5. Now, I just told you, you need to go back and check for extraneous solutions. So I'm going to take 1 and 5 and plug those back into our original equation. Well, does negative square root of 5 equal 1? We know that no, it does not. So x cannot equal 5. Now we check the other number. And we know that yes, 1 does equal 1. So our one and only answer is x is equal to 1. Here's a similar problem to the last one. Try pausing the video and working it out on your own to see if you can get it right. At this point, if I divide the -6 to the other side, then I'll end up with fractions, and I don't want fractions, so I'm simply going to square it as is. Then you're left with x is equal to 2 and x is equal to -1.